Okay, we're going to be recording this part of the session. If anybody has any objections with recording, please say so now. Okay, thank you. Okay, so the next topic we're going to be covering is the topic having to do with inverse functions. And the concept of an inverse function becomes particularly important for the topic that comes after this, that has to do with transcendental functions. We usually identify the concept of an inverse function when we work with transcendental functions. And we're going to talk a little bit about what those are in a bit, but a transcendental function, just to give you a heads up, are these functions that have to do with trigonometric functions, exponential, logarithmic, any function that can't be represented as a polynomial power function, okay? So what's an inverse function? Can somebody give me the definition of a function? You know that that's going to be in the exam, so if you can't give the definition, then you're going to be in trouble in about an hour.
A function, I have to turn on my camera.
Yes, let's keep that as a, yes, thank you very much, Andrea. Sorry about that. Go ahead.
A function from a set x to a set y is a rule of correspondence that assigns to each element of x an exact one element of y.
Perfect. Well done, Andrea. So we had defined a function. A function is this relationship that exists between two sets x and y that for every value of x, a value of y is assigned. Okay. Now, can somebody remember how we tested a function? What the graphical test of a function was?
The vertical line test.
Vertical line test, perfect. So if we have a function and we trace a vertical line in the graph, the vertical line should only intersect in one point, and that means that that's a function. Okay. Now, what is the inverse of a function? Well, the inverse of a function is when we take a function and we do a correspondence where now the x becomes y and the y becomes x. So we switch over the dependent and the dependent and independent variables. But for this to happen, or for us to be able to do this, we have to have what's called a one-to-one function. Okay. Now, what is a one-to-one function? A one-to-one function is going to be a function in which for every value of y, there is one number or one value of x. So remember this, for a function, for every value of x, there's a corresponding value of y, and that's a unique value, okay? But I might have that for two different values of x, I have the same value of y. I'll give you an example of this for a normal function. If I were to draw a parabola, for example, I'm going to have that for the value of -1 and for the value of 1, which are two different values of x, I'm going to actually have the same value of y. So for a function, for every value of x, we assign a value of y, but many values of, or a value of y can have many values of x, okay? However, for a one-to-one function, with a one-to-one function, it occurs that for every value of y, there is only one value of x, okay? So for example, a parabola is not a one-to-one function. Why? Because for a particular value of y, there can be more than one value of x. What would be an example of a one-to-one function? I'm going to draw it here on the bottom. The function that I drew here on top, this function is y equals x squared. Okay, and the important thing here is this is not a one-to-one function. Now, let's see an example of what could be a one-to-one function. Now let's graph y equals x to the 3. What happens with y equals x to the 3? If I take any value of y, for example, 1, there's only going to be one value of x. If I take any other value of y, for example, -1, there's only going to be one value of x that corresponds, okay? That's what makes a one-to-one function. So y equals x to the 3 is a one-to-one function, okay? Now, for a function, we did the vertical line test. So both of these, if we do a vertical line test, is it clear to everybody that both of these are functions? Because if I do a vertical line test for any of these, they only intersect the function in one spot. Okay? So both of these are functions because of the vertical line test. However, for a one-to-one function, there's another test we do, which is the horizontal line test. And if I do a horizontal line test, what's the difference between the horizontal line test for the parabola that's on top and the horizontal line test for the y equals x to the 3 on the bottom? What do you see there?
That it only crosses one time.
Correct.
In the second one.
Correct, Andrea. So for a one-to-one function, when I do the horizontal line test, the function only crosses in one point. That's another way of verifying if a function is one-to-one. Now, why are we mentioning this one-to-one concept? Because I can only find, or I can only calculate the inverse of a function for a function that is one-to-one. If a function is not one-to-one, then the function does not have an inverse. Now, what is the concept of an inverse? If I have f, or the function f, and f, first off, f is a one-to-one function. That's the first thing that we need to verify. I have a function f, and f is a one-to-one function. So I verified that. And f has a domain x and a range y. The inverse of f is going to be a function that's denoted by f to the -1, where now the domain is y and the range is x. So the domains and the ranges, the domain and the range flip or change. So the composition f of f to the -1 is going to give me x, and f to the -1 of f is also going to give me x for either y or x, or the range y or the domain x. Okay. Now, something very important here with regards to notation. Okay. The inverse of a function, meaning f to the -1 of x. Notice where the -1 is. Okay. It's here. This denotes the inverse of a function. This is not the same as saying f to the x -1. Okay, it's a different operation. Okay, because f to the x equals -1 is 1 divided by f of x. And that's not what we're talking about. We're not talking about the reciprocal. Okay, one thing is the inverse. So the orange is the inverse. This is called the inverse of a function. And what I wrote here in red was, which is f to the -1, this is called the reciprocal. which is basically dividing by 1, okay? And those two are different. It's important to remember that. Those two are different. We're not talking about the same thing. So right now we're going to be talking about the inverse of a function, okay? The inverse of a function, okay? We're going to go through some examples here, okay? Questions up to this? Okay. Questions here before we go on. I'm going to clear this. And we're going to do some examples. Now, the inverse of a function has certain properties, and some of these we've already mentioned. The domain of the inverse is going to be the range of the original function, and the range of the original function is now the range of the inverse is the domain of the original function. The notation we're using, f to the minus 1, the inverse is also going to be 1 to 1. Okay, that's important. So the original function has to be 1 to 1, but the inverse is also 1 to 1. And the inverse of a function is unique, meaning that the inverse function that we obtain is only obtained from the original function. So it's going to be unique. And again, you've already worked with these functions before. Just maybe you've not identified the concept, but remember, you guys identify if I have the sign operation, the sign of x, for example, right? And we're going to see that in a bit. This is the normal function, so I could have a function called f of x equals the sign of x. And remember that there's an inverse operation. So what would the inverse operation of the sign be? So the inverse of x is going to be the inverse sign of x. And you've worked with this before. When do you use the inverse sign of something? When you want to find the angle. Okay, so the sign of x, x being the angle, but if you want to use the inverse, you can find the angle given the relationship given for the angle by the sign. So notice also that when when we use it in trigonometric functions, notice that the minus 1 is right next to the trigonometric function. It's not outside. Okay. If it were outside, it would represent the reciprocal, which is a different operation. Okay. Okay, good. Now let's look at some examples as to how we can calculate the inverse. And actually, the procedure for calculating the inverse of a function is really, really simple. Really simple. So let's see these examples here. Let's look at 3 examples. Okay. And by the way, we're going to do these examples so we can practice some of the things that are going to be in the exam. Okay. So let's look at the first one. And the first one says that we are going to have f of x equals 5x minus 7. Okay, and I want to find the inverse of that function. Now, let's see if you guys are paying attention or doing something else. According to what I just explained, what's the first thing I need to verify to see if I can find the inverse of the function?
You need to graph it and check with the horizontal line test.
Yes, Andrea, perfect. And what that means, Andrea, is that I need to verify that it is a one-on-one function, okay? I need to verify one-to-one. That's the first thing I need to do. Because if it's not a one-to-one function, then I can't find the inverse. Okay? And how do I do that? Like Andrea mentioned, we can do the graph and do the horizontal line test. So this should be a piece of cake to all of you. I hope it is clear to everybody that the original function is a line. Remember that I always draw in blue the line, the original. This is the original function. And I'm multiplying it by 5. So this generates a stretch. So it's going to be kind of like this now. That's not very straight, is it? And then I am moving it down 7 units. Okay. And so I'm just going to mark it here that roughly here is -7. And where it crosses the x-axis is in 7/5. So I'm just going to mark it around here. That would be the intercept. So approximately this line is going to be going something like this. Okay. The purple line is f of x. Okay. Is that clear? Any questions there with the drawing of the graph?
No.
No.
Okay. I'm going to erase the rest of them. Okay. Now, is that a one-to-one function? Is it or is it not? And why?
Yes, it is.
Yes, it is, Estrella. Perfect. And how did you notice that it's a one-to-one function, Estrella?
Because if we do the horizontal test, we just touch 1 point.
Perfect. Perfect, Estrella. Wonderful. So if I do the horizontal line test at any part, I'm only crossing it in one place. Okay. So this tells me that it is a one-to-one function. Okay. And so if it is a one-to-one function, then I can, if it is a one-to-one function, then that means I can find the inverse. Okay. How do I find the inverse? It's actually very simple. Okay. To find the inverse. So to find the inverse, what we're going to do is the following. I'm going to take the original function, but I'm going to say that it's y equals 5x minus 7. Okay. And what I'm going to do is that I'm going to substitute the x's for y's and the y's for x's. Okay. I'm going to literally substitute the x's for y's and the y's for x's. So what does this mean? This is going to turn into so I'm going to swap them. So basically what I'm going to be doing is that I am substituting the x's for y's and the y's for x's. Okay. And now I'm going to solve for y. Okay. I'm going to solve for y. And so that means that this is going to be equal to 5y equals x plus 7. Let me do that with the same color I was when the inverse. 5y. The only thing I'm doing is solving for y, x plus 7. And so this means that y equals x plus 7 divided by 5. This expression that I found, this is the inverse. This is the inverse of the original function. Okay? Questions? Step 1, we verify that it's one-to-one. Once we verify that it's one-to-one, then we substitute, or we exchange the x's for y's and the y's for x's, and then we solve for x, and that's the way we find the inverse. Okay? Questions with this one? Okay, questions. I'm going to do another one. So questions. I am going to clear this in 5, 4, 3, 2, 1. Boom. Okay. Now let's do another one. I believe the next one said f of x equals x to the 3. And we also want to find the inverse. And the first thing we're going to do is verify the one-to-one. Okay. And so let's verify the one-to-one. This function, I actually drew it in the examples I was giving before. X to the 3, the function goes something like this. And so if we do the horizontal line test, we're going to see that we're just crossing in one point. So this means that the function is one-to-one. Okay. If for some reason, and there might be some of these in the homework task, if for some reason the function isn't one-to-one, then we can't calculate or we can't find the inverse, or the function doesn't have an inverse. Okay. Now, what do we do to find the inverse? We are going to do the same procedure. So we've got y equals x to the 3. This is actually a very simple one. Y equals x to the 3. And so what we're going to do is substitute the x's for y's and the y's for x's. And then we're going to solve for y. So this gives us y equals the root 3 of x. And this is the inverse. Okay, that's the inverse of x. Okay. Questions with this one? Okay. Okay, I don't want to write some of these things down. So again, because my writing is terrible. You found out in the Pictionary exercise that it's not that easy drawing, but you guys were very good drawing stuff. I was amazed. I'm going to erase some of this to do the next example. So questions?
No.
Okay, so 5, 4, 3, 2, 1. Boom. I want to erase everything. Okay, so the next example we've got there on the slides is f of x equals 1 divided by x. Is it plus or minus? Minus 3. Okay, let's first verify the one-to-one. So first off, this has a base function, which is 1 divided by x, which goes something like this.
Professor, it's the same if you had put the one that's in the second one on the first one.
Can you say that again, Andrea? Oh, wait a minute. I'm drawing it the other way. I'm drawing it. Yes, you're correct. Yes, yes, yes. Very well. Let's say I did that on purpose, Andrea, to see if you guys were paying attention, and you were paying attention, Andrea. Perfect. So yes, it's like this actually. So correct, Andrea. No, it was the one I was drawing was incorrect. It's like this. Okay, perfect. Thank you very much for that catch, Andrea. That's the original base function, and then we are doing a shift here. What does this shift? What type of shift is that? Can somebody tell me?
3 to the right.
Correct. It is 3 to the right. So we are going to be some. I'm just going to mark it here. This is going to be our new asymptote. Okay, and so the new function is going to go something like this. Okay, and so that's the new function. So is it one-to-one? Is it a one-to-one function?
Yes.
Yes, and correct, Juan Ignacio. And no, I'm sorry. Juan Imperial, right?
Yes.
Yes, Juan Pablo, I'm sorry. Yes, it's one-to-one, correct. If we do the horizontal line test, we're going to notice that we only intersect in one point. Okay. We're only intersecting here in one point, here in one point. And any place I do the horizontal line test, we're only going to be intersecting in one point. So this is a one-to-one function. There might be some exercises in the homework task, this next homework task, that just ask you to verify if a function is one-to-one, by the way. And you can do it using the horizontal line test. So it is one-to-one. So what we're going to be doing here is that we're going to take so we can calculate the inverse. So y equals 1 divided by x minus 3. And so we are going to substitute y's for x's and x's for y's. So that means that we're going to have x equals 1 divided by y minus 3. And next up, we solve for y. And so this is going to be equal to y minus 3 equals 1 divided by x. And this means that y equals 1 divided by x plus 3, which is the same. If we want to not leave that as a fraction, we could say that this is the same as having 1 plus 3x, which in itself is also the same as 3x plus 1 divided by x. And this would be the inverse of the function. Okay. And so again, step one, we need to verify if it's a one-to-one function. We do that by doing the horizontal line test. Next up, we do the function. We substitute x for y and y for x and see what we get. Okay. And once we do that, we solve for y and we get the inverse of the function. Okay. Questions with this one before we move on? Okay, and so the next homework task is going to have a few of these exercises to verify if a function is one-to-one, and also if it is, to find the inverse of the function. Okay. So, questions? No? Okay. I'm going to clear the drawings in 5, 4, 3, 2, 1. Boom. Okay. I'm going to switch over to the PowerPoint again. By the way, the solutions to these are here in the PowerPoint. Okay, you can find them here also. Okay, so now that we've defined what an inverse of a function is, now let's talk about transcendental functions. Okay, and these don't have to do with the engineering symposium. Have nothing to do with trascendencias. But it's very timely that we're talking about transcendental functions, and trascendencias is coming up. I hope all of you guys have signed up for the event. It's going to be really cool. I know the organizing committee is really working hard, and I really commend them for the work they're doing to have this event this year. I don't know if you guys know this, but trascendencias, well, not trascendencias per se, but the engineering symposium of the Mexicali campus, I believe it's the longest standing academic event that has occurred in an uninterrupted way year after year since its beginning. So there's never been a year without an engineering symposium. That's it. This is important. It's important because right now in this time that we're living in 2020 with the pandemic and everything's halted and all that, I really commend the organizers of the event that the event is going to happen. And I'm really proud of that because the event has gone uninterrupted for many decades. And so that's great for them. But just as a trivia, SETI's trivia, who was the faculty, the professor that who was the counselor for the first engineering symposium ever at SETI's? Do you know that? SETI's trivia. Guillermo Chang. Guillermo Chang was the professor that was the support guiding professor for the first engineering symposium at SETI's. Now, this is the next part of the trivia. Who was the professor for the first trascendencias? Now, while you think about that, trascendencias, the first time that the event was called Trascendencias was in 2001, I believe. Before that, the event was called the Engineering Symposium, and each time it had a different name. So every year it was a different name. It didn't have a brand. In 2001, I believe it was 2001 or 2000. I think it was 2001. The engineering symposium started calling itself Trascendencias, which I believe is a made-up word. But as Thor says in Avengers Endgame, all words are made up. And after that, up to this point to 2020, which is almost 20 years, the event has always been called Trascendencia. So who was the faculty advisor for the first Trascendencias? Anybody want to take a guess? I'll leave that as an open trivia for you guys. So a transcendental function, what is a transcendental function? A transcendental function is a function that doesn't satisfy a polynomial equation. Meaning that, for example, a polynomial equation is like the equation for a parabola, okay? Or any sort of power combination, or that can be represented as a polynomial. And what are examples of transcendental functions? Well, you know these and you've worked with these before. Trigonometric functions are examples of transcendental functions, as well as logarithmic and exponential functions. So that's going to be the next section of work that we're going to be doing. And so first, let's talk about the sine and cosine functions and how are these defined. This is the definition of the sine and the cosine. So first off, there's a concept here that's called the unit circle. This thing here that's in this circle that's in blue, it's called the unit circle. And what is a unit circle? It's a circle that's centered in the origin and that has a radius of 1. Okay, that's why it's called a unit circle. So it's a circle that's centered in the origin and has a radius of 1. And the sine and cosine functions are defined with regards to the unit circle. And so for a unit circle, that's the circle that's centered in 1, if we identify a value, and that value is, we're going to call that value t, which is basically the angle that occurs between the x-axis and any line that goes from the origin to any point in the circle. And that line is always going to have a radius of 1. We're going to have, automatically, we're going to have a right triangle that's generated here for that angle. And so for that right triangle that's generated for a unit circle for an angle t, we define the sine of that angle as y, which is the y coordinate. And we define the cosine of that triangle as x. And so the sine is going to be the relationship that exists between the opposing leg of the triangle, which in this case is the y coordinate, and the hypotenuse, which in this case is 1. The cosine is going to be the relationship that exists between the adjacent leg of the triangle and the hypotenuse, which in this case is 1. Okay, and so by the Pythagorean theorem, we have that we know that x squared plus y squared, which are the two legs of the triangle, have to be equal to the hypotenuse squared, but the hypotenuse is 1. Now, if x equals cosine and y equals sine, then automatically we're going to have our first trigonometric identity, which is one that you guys, I'm sorry, this is a plus, I'm sorry, plus, which is a trigonometric identity that you guys know very well or should know very well. It says that cosine squared of t plus sine squared of t equals 1. So many of the trigonometric identities that we're going to be working with come out of this, this concept. Okay. And there's a series of other functions that are defined relating to these, which are the tangent, cotangent, secant, and cosecant. Okay. And the tangent is going to be the relationship that exists between y and x, or another way of representing the tangent is that it's going to be the relationship between the sine and the cosine, according to the definition that we just gave. And these functions that we have here, these are actually the reciprocals. So the cotangent is going to be the relationship between cosine and sine, but that relationship is also 1 divided by tangent, or the reciprocal. The secant is going to be the relationship that exists, or the reciprocal of the cosine, and the cosecant is going to be the reciprocal of the sine. And these are going to be the basic trigonometric functions that we're going to be using. And these relate all of the possible or different combinations that can occur between x, y, and in the right triangle that is formed by the angle t. And so basically we have 6 basic trigonometric functions, which is sine, cosine, tangent, cotangent, secant, and cosecant. And those are going to be the 6 trigonometric functions that we're going to be working with. Okay? And basically something that sometimes is a headache in math for some of you is that we're going to be working with identities and kind of working on how to use identities to simplify or demonstrate that simplify expressions with trigonometric functions, or demonstrate that expressions with trigonometric functions are equivalent. Okay. Okay.